Hello and welcome to this short video where we're going to take a look at the log4j vulnerability and how Sysdig can help detect its presence in your environment. The log4j vulnerability has been gaining a lot of media attention lately because it is such a critical vulnerability in that it allows an attacker to run arbitrary code in the context of one of your Java applications. This is done through the exploit of a standard API interface in the log4j utility, which is commonly found in many Java applications. And through that exploit, an attacker can download arbitrary code from an LDAP server, which then gets executed in the context of that Java application. Taking a look at how Sysdig can help you with the detection of this. First off, we create an image scanning profiler policy, where we are looking at the detection of specific vulnerabilities within a container image. So when we scan the container image, we will look for the operating system packages, but also the libraries from a number of runtimes, and then match those versions against the known vulnerabilities. And in this case, we're looking for the specific vulnerabilities that are referenced with the log4j vulnerability. When we apply that policy to an image scan, then this gives us the ability to fail that scan. And through the use of Kubernetes admission controllers, for example, within Sysdig, we can actually block deployments of images that contain these vulnerabilities. And as you can see that this particular image, which is a log4j application, has failed based on our policy evaluation. And if we take a look at the non-operating system vulnerabilities within this image, you'll see there's a number of log4j vulnerabilities detected in there. And it's telling us that this is a critical vulnerability in this particular version of log4j. And these are the versions where that vulnerability has been fixed. So as a developer, as a security operations professional, I can now inform the relevant people that they need to upgrade that package, that library within the image, rebuild the image, and deploy again. So that gives us a point in time of detecting this vulnerability these vulnerabilities in specific images. Going a step further, as a security operations executive, I might then want to look at where am I vulnerable at runtime as well. So developers building new images will get notified straight away in their CI/CD pipeline potentially that they've got this vulnerability. But if I want to take a look at historical images that are already out there running in my environment, I can construct a report in Sysdig which gets run on a specific schedule. So this can be daily, weekly, or monthly, and have the results emailed to me. And in this case, I am looking for a runtime report of specific vulnerabilities, where again, I'm looking for those same vulnerabilities that were in that policy. And I can restrict this to segments of my infrastructure based on some metadata. But in this instance, I'm looking for across all the infrastructure where I'm using Sysdig to protect it. And when I run this report, if I take a look at the preview now, you'll see that I've got these specific vulnerabilities showing up in my environment. And this report will then be downloaded to me where I can use it to manipulate to help then inform the relevant developers that they need to fix this application. But it'll also tell me as I scroll across where this environment, so where this vulnerability, where this image is in use in my environment in the Kubernetes context. So in terms of then mapping my real runtime exposure, that will help me detect where I'm vulnerable, and particularly if I have this present in production environments, so that I can take the necessary remedial action. Hopefully you found that useful, and thank you for your time.